Hello, my name is Ken Jacob. I'm an engineer who worked at Bose Corporation for 36 years after graduating from MIT. My wife and I have raised 3 children who all attended public schools in Framingham, Massachusetts. A few years ago, as part of helping one of our kids, we discovered a major error built into the way grades are calculated in the United States. An error that affects virtually every student at one time or another. And it was hiding in plain sight. The error, it isn't subjective or debatable. It isn't part of the controversy about whether it's okay or not to give zeros for missing work. It's not about whether late assignments should be given partial credit. It's a simple mathematical error that results in giving students the wrong grade. This is about inaccurate grade averaging in US schools and how to fix it. We'll begin by considering 2 students, Abby and Percy. They're taking the same English class, but in 2 different classrooms. In Abby's classroom, the A to F grading scale is used. But in Percy's classroom, the 0 to 100% scale is used. Now, both kids ace the first assignment. Abby gets an A, and Percy gets a 100. But unfortunately, both failed to turn in the second. So Abby gets an F, and Percy gets a 0. Let's take a look at this graphically. On the A to F scale, Abby got an A on the first assignment and an F on the second. And on the 0 to 100% scale, Percy got a 100 on the first assignment and a 0 on the second. First, let's do the average for Percy. To average 0 and 100, you just add them and then divide by 2, and you get 50. Now let's go ahead and average Abby's grades. We can use a simple balancing technique where we move pairs of grades closer together by the same amount, because that won't change the average. So an A and an F is like getting a D and a B, and that's like getting 2 C's, which amounts to a C average for Abby. But wait a minute. An average of 50 for Percy is a failing grade, because anything below a 60 is failing. But Abby got a passing grade of C. How can that be? Because after all, both kids performed equally, right? But if this trend were to continue, Abby would get a C on her report card, which converts to a GPA of 2.0, but Percy would get an F on his report card, which converts to a GPA of 0. Both averages can't be right, and that means that someone is being treated very unfairly. So which average is correct? The obvious and intuitive answer is that the C average is correct and the 50 average is wrong. But why? After all, 50 is definitely the average of 0 and 100. But we know that Percy should not be failing. So something must have gone seriously wrong when we averaged Percy's grades. And in a moment, we'll see exactly what that error is. But before we do, how should we size up this error? Is it a big error or a little one? Unfortunately, the vast majority of classrooms use the 0 to 100% scale, not the A to F scale, which is why this error is so widespread. Now, some teachers watching this might be saying, but I use the points earned versus points possible system, not the 0 to 100 scale. Does that mean I don't have the error? Unfortunately, no, because the points earned system is really just the 0 to 100 scale by another name. And I'll show you why. The reason is that getting a 10 out of 20, for example, on a 20 points possible scale is the same as getting a 50 out of 100 on a 100-point scale. They're both 50% achievement. And that would still be a failing grade for Percy. So unfortunately, the error remains. So somehow, when grades are averaged using the 0 to 100 scale, the scale that's used overwhelmingly in US schools, something is really going wrong. But how wrong? Let's go back to Percy's grades. He has a 0 and a 100, and that averages to a 50. How many more perfect scores would he need to earn to get the average grade that Abby got, the one that he deserved in the first place? If Percy gets one more perfect score on a third assignment, his average would be a 67, which is a D, and still not good enough to get a C like Abby. Actually, Percy has to get a perfect 100 on a fourth assignment to get an average of 75, which would be in the middle of the C range, like Abby. In other words, the error in grade averaging means that Percy has a very big hole to dig out of. He has to earn 2 more perfect 100s just to get the grade average he deserved in the first place. That is not a small error. Unfortunately, the 0 to 100% scale is the dominant scale used to average grades today. And worse, the error is then converted to an A to F grade for report cards, and then to the GPA scale used in high schools, colleges, and universities. In other words, for Percy, the error in grade averaging started in the classroom, but then followed him when report cards came out, and followed him again when he might be thinking about college or graduate school. So now, finally, what exactly is the problem with averaging on the 0 to 100 scale? The problem is that the 0 to 100 scale is not broken up into equal grade intervals. One interval, 0 to 60, is 6 times larger than the other intervals. If the scale had been broken up into equal intervals, it would look like this. But it doesn't look like this. It looks like this. And under such circumstances, there's a scientific and mathematical rule that says that you cannot perform arithmetic, including averaging, on a scale that does not have the equal interval property. And it says that if you do, you'll get the wrong answer. So this is where the error occurs. It's because we're averaging grades on a scale that fails the equal interval test. And when we do, we're getting the wrong answer. In a moment, we'll learn how we can mathematically and properly average grades on the 0 to 100 scale and fix the error. But first, as a point of human interest, how is it even possible that we could have missed this error for so long? The answer is in the fact that we are all so used to averaging other things on the percent scale. And when we do, there's no error when we do it. For example, it's perfectly okay to average the percentage of bacteria growing in a set of biological samples. And many of us did exactly this kind of thing in school, and some of us do it all the time at work. The truth is, we've been averaging percent scores all our lives, and we've mostly been doing it right. But the difference is that these other percent scales all satisfy the equal interval requirement. And I believe it's because we're so used to legitimately averaging percent scores, we've assumed it's okay to do so for grades. But it's not, because when we do, we introduce a big error. And that's because the 0 to 100 grading scale does not have equal intervals. One of the intervals, from 0 to 60, is different from the rest. 6 times different. So what can be done to fix this? Luckily, the fix is very easy, and it can be implemented right now, right where grade averaging occurs, usually in the software program the school already uses. Teachers don't need to change how they grade assignments. Report cards don't need to change, or transcripts. It's just a matter of swapping the right formula used for averaging for the wrong one. Nothing else changes. All we have to do is convert grades on the 0 to 100 scale to a scale that does have the equal interval property, and then perform the average. It's that simple. So to see exactly how to do this, let's start by looking at things graphically. Here at the top, you can see the 0 to 100 scale. And below is a scale that has the equal interval property that we need. We'll simply call it the grade averaging scale. As we've already seen, the 0 to 100 scale has 5 grading intervals. For simplicity then, we can divide up the grade averaging scale into 5 equal intervals. And now it's easy to put numbers on this scale. It goes from 0 to 5. To do grade averaging properly, we simply have to map these unequal intervals on the 0 to 100 scale to the equal intervals on the grade averaging scale, like this. And then it's easy to see how conversion from one to the other is done. For example, a 0 on the 0 to 100 scale converts to and is still a 0 on the grade averaging scale. A 75, which is in the middle of the C grade interval, converts to a 2.5 on the averaging scale. And a 100 on the 0 to 100 scale converts to a 5, and so on. So now let's go back to Percy's grades and do the averaging properly. His 100 converts to a 5.0, and his 0 converts to a 0.0. So the average would be 0 plus 5 divided by 2, which equals 2.5, and is right in the middle of the grade averaging scale, as it should be. Then, from the averaging scale, we can easily convert the 2.5 to a C on the A to F scale. Or we can go the other direction, from the averaging scale to the 0 to 100 scale, because a 2.5 on the averaging scale is a 75 on the 0 to 100 scale. Again, exactly where it should be. So, as you can see, now we have a simple way of moving accurately between any of the scales. The error is fixed for Percy and everyone else. Okay, so far so good, but some of you might be thinking, okay, this all makes sense, but in my classroom, assignments are weighted. Exams are worth more than quizzes, which are worth more than homework, and so on. Everything you've shown me so far assumes that all the assignments are equally weighted. That's true, but only for convenience to help explain the error and its fix. I'll show you that including weighting is simple. First, we have to review the 2 different ways that weighting is typically used. In the first, every assignment is graded on the 0 to 100 scale, and the teacher tells the students at the start of the term how much each assignment is to be weighted in the computation of their final grade. For example, a project and quiz might be weighted as 25% and the final exam 50%. In the second method, assignments are pre-weighted by how many points the assignments are worth. To use the same weights as the first method, the project and quiz would be worth 25 points and the final would be worth 50 points. But really, when distilled, these 2 methods are the same, because each of the grades is just a percentage on the 0 to 100% scale. As an example, a 30 on the exam is just a 60% grade on an assignment that has a weight of 50. Regardless of which method of weighting is used, the process to average grades is simple. Convert individual assignment grades on the 0 to 100 scale to the grade averaging scale. Then apply the weightings, then average. And remember, the error correction in grade averaging takes place behind the scenes in a school's information systems. Nothing changes in the classroom, nothing changes with report cards, transcripts, or anything else. The exact details on how to do all of this are in the free paper I've linked to below. So now it's time to wrap up. I'm very glad that you've watched this video, and I encourage you to make comments below. You now know we have a big problem with how we're averaging grades in US schools today. You know that the error is hurting many millions of students, and you know it's easy to fix. If you're a stakeholder, a student organization, a parent-teacher association, a teachers union, administrator, IT professional, academic, politician, whatever, and you need my help, you can contact me using the link below. I'll work with any of you to fix the problem and do the right thing for our students. Thank you.